This video is made available by the Allegheny College Computer Science Department under a Creative Commons Attribution Non-Commercial No Derivative Works version 3.0 license.
So in the previous movie, we started to fill in the code in our IntegerStack, and we did isEmpty. Now, we can now check to see if the array list that represents the stack is empty. We declared it, we allocated it, and then we can check if it's empty. Now I'd like to be able to, let's see, what should I do next? I think I'd like to be able to put things into the stack. So I'm going to be given a number in the push method, and I want to put it onto this array list. Let's go back to the documentation. I could put it at the start of the list, so I could insert the object at index 0. Or I could just use the add method and put it at the end of the list. So that means the top of the stack is the end of the list. I'm going to go with that approach because it seems like it might be simpler. It could be we could do this either way. I'm going to put things at the end of the list and pretend that is the top. So to add a number to the stack, I say the stack add the number. It compiles. Does it work? Well, I could pop things, but let's find out. Hang on. So I'm going to create a new integer stack. Okay, is it, and I'm going to push the number 8. 8 is a good number to test with. 42. Oh, 42. I mixed up my tests. All right. So now inspect, and there's the list. Now I'll go into it, and in the first location of the list, 42. Now it's at the first location right now, but that's because it was an empty list to begin with. So it looks like I successfully pushed something onto it. Now the next thing, I could try and pop that from the list, but actually I forgot a method when I did my outline. I forgot peek. Peek returns the top integer from the stack. Pop should return and remove. Yeah, there we go. Removes and returns. Now I have my comments correct. So peek will just look at the top of the stack and tell me what's there. It's going to cheat. So if I'm putting numbers at the end of my list, and that is the top, that means to see what's on the top of the stack, I should return whatever's at the end of the list. So the stack.length should be the index if I'm going to get something from it. So yeah, we add things to the end. So we find out how long it is, and we return whatever value is at the end. And that should do it. It should be a one-liner. Yeah, finish the comment. Maybe it's size. Is it the stack.size? No, size is private access. What does that mean? So when you're in doubt, you know what this means. It's time for the documentation. And we look around, and what do we find out? Size on array lists is a method. Remember, this is not an array, it's an array list. So I have to call the size method to find out how big it is. So I'm going to get the element at the end of the array. So I'm not the only one who does this. I've seen students do this a lot. Is it length? Is it size? All right. And, when we get things from an array list, it returns an object. But peek has to return an integer. I'll cast that object as an integer. How about that? Oh, I can't convert an object into a primitive type. There's a fire. You hear that? Something's on fire. It's not this building. So, here's the trick. I can cast an object to an integer object. And then I can take that integer object, and I think I can get an int out of it. So let's search for integer. There's integer. Let's look at this class. Look around the documentation. How do I get an integer value out of this thing? Ah, there it is. int value. That'll work for me. So on the integer object I just declared, I will do I dot as int. I have such a short memory. Holy cow. Hang on. What was it called? Int value is the name of the method that returns an integer representation of an integer object. Okay. Int value. Let's spell that correctly. So we get an object back from the array list. We cast it to an integer object. Then we ask that integer object to give us the int representation. That's pretty tricky. The nice thing, though, is that by writing the peek method, we have hidden this complexity from our user. So encapsulation saves our user from having to deal with this complexity. That's part of what encapsulation is for. So now I can come in and I can push a number. 8. There we go. And we can peek. Ooh. Let's see. My array list only has one element on it. What does it say? Index 1, size 1. Oh. Look at that. Of course, my integer is at location 0, so I shouldn't look in location 1. So I'm going to subtract 1. I peek, and 8 comes back, and that's not bad. And I can create another one, and now I'll peek at an empty stack, and ooh. Because there's 0 things, and I try and look at the -1 spot. Clearly this code needs more work. We can't just subtract 1. So I'm just going to put a comment here, and I'm going to say this is badness 10,000. It's very bad. Holy cow. So we're going to have to fix that later, and it'll probably be something you need to do, not me. For now, I think it's enough for you to see that obviously this is a bad thing. Alright, exercise for the viewer. But that gives us a way to put numbers on the stack and a way to peek at the last, or the top element, I should say, which happens to be the last element of the array list. And that is enough to get us moving.